Good afternoon, everyone. My name is Aishwarya. I am here to present my project on CO2 emission estimation from fuel type, annual mileage, and the engine side. And our project focuses on CO2 estimations from the vehicles are major contributors like for air pollution, global warming. So, for making that to protect the environment, so we are using this project for the user. Engine size is directly affects the fuel type. Like generally, if engine if is more and fuel will burn more. Like in a fuel type, it plays a crucial role as a different fuel releases different amounts of carbon dioxide. Like diesel release less, petrol release more. Like that, it release different amount of carbon emissions. So mileage is influence emissions per kilometer. If mileage runs more per year, then the CO2 emissions will be less. So I am importing the library. Then data is loaded. The data set is the 1000 rows and 11 column, where 11 columns are. These are the 11 variable column. We can see there are 4 categorical data and 7 numerical data. This is the description of this data set. Now we are processing the missing value analysis and the data imputation. In missing value, there are so many missing values we can see here. So to implement the missing value, how to handle? We are using data numerical and categorical column. Numerical is done by the mean and median, and categorical is done by the mode to handle the missing values. Now we can see that engines we can see after that missing values will be null, so the missing values is handled. This is used for standardizing the column names dynamically, identify the engine related columns, and input the missing value using to mean to ensure the data is clean and ready for model training. EDA and data visualization. EDA is the exploratory data analysis, where we can see the distribution of target variable carbon dioxide by univariant and bivariant distribution. In this univariant, this creates the distribution of float of CO2 emissions. It shows how the value spreads low or high for the vehicles, and in this graph we can see it normal is bell shaped, and screwed right is more low emission vehicles, and screwed left is more high emission vehicles. This is the numerical future distribution. It is the univariant, where we can see only single value like engine size, annual mileage, vehicle age, and CO2 emissions for univariant. Correlation heat map. In this we can see red, blue, and white color. Red declares the strong relationship between the numerical features. Blue it indicates blue less relationship, and white it indicates no relation is not there in that. So we can see the make complex numerical relationship easy to understand easily. Now it is a univariant graph, where we can see CO2 versus engine size. The dots represents the vehicles, and here we can see engine size versus engine size in the x-axis, and engine size in the x-axis, and y-axis we can see CO2 emissions. This is CO2 versus mileage, which used for the to see the annual mileage and the CO2 emissions of this. It is CO2 by vehicle category. We have 4 types of vehicle, where we can see hatchback, sedan, truck, SUV. So which release how much CO2 we can see by this. We can plot the graph. Now CO2 by fuel type. This automatically finds the columns related to fuel type and CO2 emissions, making it flexible for the different data types. It creates a blocks plot to the compare emissions across the fuel categories. We can see in this we can see the fuel types of fuel: petrol, CNG, hybrid, LPG, and diesel. How much it will produce the carbon dioxide rate, that outside line is more and down lines is very less. Middle line will decrease the correct emission of CO2. These are the different types of regression. First one is linear regression. In linear regression, the accuracy is the 0.02, and in ridge regression we can see accuracy 0.02. In lasso regression also we can see the accuracy scored as 0.02, but in random forest it shows 0.04. So it has the highest accuracy compared to all. These are different types of convolution classification, in which in neural network it has a multi-layer perceptron, handles a complex patterns, which it has an accuracy of 50%, and the k nearest neighbors, which classifies the nearest data points of the graph, and which shows the small data sets. So it has the accuracy of 38.5%. Decision tree classifier. It is a tree-based model, easy to implement, and handles a non-linear data. It has an accuracy 35.5%. And random forest classifier. It is used to assemble the often multiple decision tree and high accuracy and reduce the overfitting of the graph. So we can see the accuracy as 36.5%. Logistic regression. It is used for the logistic based, and it has the accuracy of 32.5%. So after considering all the neural networks, we can get the neural network has the more accuracy. So we are training the neural networks for the classification. After training, we will get the this we are training the model. After training the model, we will get the confusion matrix. Confusion matrix code, where the neural network predicts high for all samples, true value and medium value, and correct high value. So in this we can see the graph of the confusion matrix. 16 is a very low, 29 is high value predicted value, and 24 is high predicted value. 29 is medium predicted value, which in the diagonal numbers it shows the correct predicted values, which is other numbers which is the non-unpredicted values. This is the graph for the confusion matrix. Next we are deploying the code for training the model. After deployment we get the output as this. In this we can see three variables, where engine size, fuel type, and annual mileage. Engine size of the we have four vehicles in which we can add this. First vehicle is hatchback. Hatchback is a small vehicle where it can be fit 3 to 4 members. So engine size of that hatchback is 1.0 to 1.5 liter. Next fuel type of that vehicle is petrol. Next annual mileage of that hatchback vehicle is 10 km to 15 km. So we can see the output of this. We can see the carbon emission 187.28 gram per kilometer. Now we can see sedan, which is bigger than hatchback, where it can fit 3 to 4 to 5 members for family trips and their use. So engine size of that sedan is 1.1 to 1.5 to 2 liters. Fuel type it can be petrol, diesel, anything, and annual mileage will be 10 kilometers to 18 kilometers. So we can see that. To 18.16 gram per kilometer, where we can see this estimation of CO2 emission in sedan, and sedan it has even diesel also. it has 238.551, and in SU we see the third character where we can see 2.0 liter, and it is used for HUDC is used for electric, and liters can be in 18,000. So annual mileage will be in 18,000, and fuel type will be electric hybrid, with which will be anybody it will be, and engine size it will be 2.0 to 3.5 in engine size, and estimated as 148.92. Last one is truck. So engine size will be more for truck, like up to 6.4 liter it will be, and fuel type will be only diesel for truck. If it is a pickup truck, means we can use hybrid or anything, and in annual mileage will be up to 30,000. So we can see 5. So 184.13. In this we can see electric vehicle, electric fuel will be less carbon emission, and next diesel also uses less carbon emission, but petrol uses more. In this, by this they can predict the carbon emission of the vehicle. Thank you.